Namaste. How are you all doing this afternoon? Good. Are you tired? Are you sleepy? It's the end of the day. You've not had enough chai to stay awake. Will you be able to stay awake through this? Yes? All right. Thank you so much. Today we're going to talk about framework-free web development. And let me establish up front that I have spent a large part of my career talking about web frameworks. I have worked in React, in Angular 1, in Backbone, going back and back to Prototype and Scriptaculous. I've spent a lot of time in web frameworks. Some people come out of this talk and say, why do you hate web frameworks so much? I say, I don't hate web frameworks so much, but there are some things I'm very concerned about with this modern crop of frameworks, and we'll have an opportunity to address that. So, Sadia, right? Oh, I love coming to India. So many little tastes. So imagine that you invite me to your home for Sadia. And I say, ooh, I'll bring naan. And you're skeptical, but you're exceedingly polite as well, right? And so everyone is seated around the table. They said, oh, we can hardly wait to get Scott's naan. And I come out of the kitchen and I say, ta-da, here we are, naan. And you say, wait a second, that banana leaf looks like it's made out of plastic. I said, no, that's okay, it's naan, right? These are the raw ingredients of naan. This is flour and water and yeast. And you say, my guests can't eat this, right? It's not like you can take a little bite of flour and a little pinch of yeast and wash it together with water and end up with delicious naan in your mouth, right? I've clearly missed an important aspect of Sadia, that really what we want is the finished product, not the raw ingredients. Are you with me so far? Yes? Then how come at software conferences such as this, we focus on the raw ingredients and we never focus on the finished product? Now, the raw ingredients are crucial to a delicious naan, right? If our HTML is our flour, this is the body, this is the structure, this is the content of what we're trying to deal with. And if we mix in a little bit of CSS, a little bit of water, it allows us to shape the content, give it form and structure, yeah? But this isn't bread until we breathe life into it with yeast. Yes? So all three of these raw ingredients are crucial to building naan. How many of you are JavaScript developers in here? Yes? This is the appropriate ratio of these ingredients as well. That might be hard for you to hear. I'm a JavaScript developer as well, right? No chef is going to say, you know what, I think I'm going to use less water and more yeast. As a matter of fact, I'm just going to implement water and yeast. That wouldn't work, would it? Yet we're talking about implementing CSS in JavaScript as well. So really, what we're faced with when we focus on the individual ingredients rather than the finished product, we are victims of Conway's Law. Have you heard of Conway's Law? Are you familiar with this? This is a developer back in the late 1960s named Melvin Conway. And the way he explains it is a little bit hard to understand. We'll uncomplify it in just a moment. But he says organizations which design systems, which design software, end up producing software that are copies of the communication structure within the organization. What they're saying is the software a company builds ends up looking like the organizational structure of the company that built it. Yeah? He goes on to say, and this makes it a little bit easier, that a software interface of a system will reflect the social boundaries of the organization that produced it. And all of a sudden, we begin seeing a slightly clearer picture of what we mean by Conway's Law. Did you know that if you work at Microsoft, at least historically, things might have changed, but every developer at Microsoft got their own office with a door that locks? How do you think that speaks to collaboration within Microsoft? Might that explain why every time you update Word, your browser breaks? Yes, this is Conway's Law in action right here. How many of you work in an organization that has DBAs, database administrators? Of course. How many of you work in an organization where the DBAs all work in a separate department? Of course. In a separate area of the building? Perhaps with a door that locks? Yes. When we broaden this out, we begin seeing that Java developers, who of course are a separate department, yes, when they have to interact with DBAs, there's social friction when those two departments try to interact with each other. Java developers end up developing things like Hibernate in order to avoid dealing with DBAs in another organization, right? We can solve this here and not have to worry about that over there. What's the problem with Hibernate? Have you seen the database schema that comes out of Hibernate? It gives DBAs nightmares, doesn't it? As a Java developer, you say, this is fine, ship it. And a DBA says, this is not fine at all. Similarly, though, I've dealt with DBAs, especially young, shall we say, enthusiastic DBAs that would like everything to be in the 12th normal form. They say, I've been looking through your data and you seem to be reusing the word the an awful lot. So I've created a table with common words and all you have to do is create a one-to-many join. So anytime you're using common words, you can just insert the foreign key and we'll solve that data. That's a nightmare as well, isn't it? That is Conway's Law. That's Conway's Law that we're experiencing right there. Now, we're all having a good laugh at the Java developer and DBA's expense, but this Wikipedia article goes on in just a paragraph or two later to call out corporate websites specifically. They say that organizations often produce websites with a content and structure which mirrors the internal concerns of the organization instead of the internal concerns of a user. This feels much like me serving you naan, right? Or proto-naan, or the raw ingredients of naan, but not serving you naan. If this is what your organization looks like, you're not set up for success. You're not set up for success because, again, I love talking to young, enthusiastic JavaScript developers fresh out of university or fresh out of a boot camp say, yes, I'm a full stack developer. I say, oh, that's great. Full stack. Yes, I understand Kubernetes and Docker containers and all these. They say, oh, that's wonderful. See, I've got a problem with CSS over here. And they say, hold on. I said I was a full stack developer, right? I can't help you with CSS. Full stack, huh? Interesting. Thank you. Yes. So today I'm going to teach you how to bake bread. Today I'm going to teach you how to use HTML and CSS and JavaScript all together because that's the only way we get to make bread. We need to have all those key ingredients in the right ratios. But we have to respect each one of those ingredients. And interestingly, the New York Times, when they published a recipe very similar to this, a simple 3-ingredient recipe, It has gone on to be one of the most popular recipes on their website. Over a decade, this 3-ingredient bread recipe is what continues to get downloaded. So there's something to be said for baking bread with simple ingredients. So, we're going to hear from this gentleman quite a bit. Alan Perlis was a software developer, way older than you and I combined. He was one of the fathers of the ALGOL programming language, but he's also well known for having pithy, intelligent, sometimes funny quotes. And so he says that a language that doesn't affect the way you think about programming isn't worth knowing. And so in Act 1 of this presentation, we are going to talk about semantics, not syntax, which is probably a different way than you were taught. I know when I was taught HTML, they said type in this element, type in this element, type in this element. When they taught me CSS, they say put your curly braces here and your colons there. When I learned JavaScript, they said put your curly braces there instead of there, right? But by focusing on the syntax, we lose the semantics of what we're trying to solve. Form follows function is an old saying from the architecture, not software, but building architectures. Frank Lloyd Wright, a very famous architect, and his mentor, Louis Sullivan, and then his mentor before that, repeated this to themselves: form follows function. Which means when you walk into a building, it needs to be functional first. You need to be able to find the front door. You need to be able to find the elevators and the bathrooms, the toilets, the water closets. You need to be able to find your way around. How it looks is secondary to the functionality of that building. And so where form follows function is what we can do to describe buildings. I like saying syntax shadows semantics when we're talking about software development. So, here is our bread recipe. I know the text is small. The details are not important. I make it small so we can begin seeing the forms that it takes rather than the individual details. But this is your bread recipe in text. We see our 3 ingredients there. We see instructions on how to build all this stuff. And I say, there you go. Publish this to the web. You're now a web developer. I say, well, wait a second. I'd like maybe some of the text to be bigger than some of the other text. It's like, oh, in order to do that, you're going to need HTML. Well, and I'd like to add some colors to this as well. Yeah, for that, you're going to need HTML. And images. Would it be nice to add images? Yeah. For images, you're going to need HTML. So fine, Scott. Well, can we convert this to HTML? I say, yes, absolutely. Take bread.txt, rename it to bread.html, and there you go. You're done. Thank you, everyone. That's all the time I have. I appreciate it. And you say, wait a second. That looks worse than the text version. I say, I know, right? Welcome to being a web developer. This is your first lesson. Have you heard people say that if you give a person a program, they'll be frustrated for a day? But if you teach them to program, they'll be frustrated for the rest of their life. So this is your first lesson right here. And in fact, this is a very important lesson. This is maybe the most important lesson. This is what your browser wants to do with data. It will not pay attention to carriage returns. It will not pay attention to multiple spaces. We will see that that data will flow like water through your browser. It is your job to add semantics to this to make it look better. So in order to do that, we're going to read the specifications together. I have been asking this question for several years now at GIDS. So for nostalgia's sake, let me ask this to you again. How many of you are web developers here in the room right now? Show of hands. Almost everyone. Very good. Hands down. How many of you have read the HTML spec? Hands up. Wait a second now. What happened here? How come 3/4 of the room said they were web developers and 5 very shy people raised their hands like this and looked over their shoulder? You must be incredibly intelligent if you decide to be a web developer never having read the rule book. You must be exceedingly smart. And my hat is off to you. I'm not wearing a hat. You can see my hat is off to you, yeah? So since you haven't read the spec, this is your lucky day. This afternoon, I hope you're comfortable. I'm going to start reading the spec to you, all right, at the very beginning. So here we go. Introduction, section 1.1. HTML is the World Wide Web's core markup language. All right, so we know that HTML is hypertext markup language. Very good. The very second sentence of the HTML spec says, HTML is primarily designed as a language for semantically describing scientific documents. So Tim Berners-Lee, who we talked about this morning when I was on stage, the inventor of the World Wide Web, he invented HTML. He invented HTTP, Hypertext Transport Protocol. He wrote the first web server. He wrote the first web browser. He did all this while he was at CERN. CERN is the Large Hadron Collider, right? This is where they're doing all these scientific things. So this all checks out. This was all written by Tim Berners-Lee when he was at CERN to semantically describe scientific documents. Now, I've used that word semantic enough to frustrate you. What does semantic mean? Well, semantic, ironically, is all about meaning. So when you're semantically describing your documents, what you are literally doing is adding meaning to your documents. Isn't that lovely? Isn't that a wonderful calling? All of you who raise your hand in here, your job is to add meaning to the world. That's very important. That's very powerful. So these semantics that we're going to be talking about are going to come up over and over again. Of course, I was kidding. I wasn't going to read the entire spec to you. Some people got excited. They said, all right, let's go. They had popcorn. They were ready for it, right? Yeah. All right, I lied to you. It won't be the last time I lied to you on stage, but I lied to you. I'm not going to read the whole spec to you. But if we look at the table of contents here, I covered the introduction for you. You don't have to read that. We talk about common infrastructure. Oh, and there it is, semantics again. Semantic structure and the APIs. So it says documents are built from elements, those pointy angle braces, right? And so when we saw bread.html, it was lacking those pointy elements. It was lacking meaning. It was lacking semantics. So what we do with these elements, though, is these elements form the DOM, the document object model. See, when I was taught HTML, they said if you wrap something in H1, it makes the text really big, right? If you put it in an H2, it makes it slightly smaller. And H3 slightly smaller again. None of this was giving me the idea that I was building up a document object model in memory. All this was telling me that I was changing the way it appeared on the screen. And so this is why I'm going to keep harping on this idea of semantics. Semantics have nothing to do with appearance. Semantics have to do with meaning. So when we get into chapter 4, the elements of HTML, each element has meaning. A paragraph means something. An image means something. An input field means something. It's not until we get to chapter 8, the HTML syntax, that we begin talking about how to do this. Syntax shadows semantics. We're 8 chapters into this spec before we even talk about the syntax. That gives you an idea of the relative importance of syntax over semantics. And you have to wait until chapter 10 to see rendering, so that shows you how unimportant the appearance is in relation to the meaning of the elements that you're adding to your document. Are you with me so far? Yes? Lovely. Thank you. So what is this? Some people say, well, this is sheet music. That's like saying this is flour and water and yeast, right? Do you know what this is? This is Mozart. This is a symphony by Mozart. But what he's done is he's serialized this symphony for us. What he's done is he's given us a way to reproduce this symphony by any player who knows how to read the syntax. So of course we have notes. That's like the HTML, right? These notes are saying dot 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 dot. But there's much more meaning to that. Those eighth notes that we see in there, those little dots underneath each eighth note, that means staccato, right? So instead of singing it as dot 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 dot, the staccato tells me I should sing it dot 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 dot. The pianissimo and the fortissimo. It's all Italian, right? Yes. So pianissimo means play it very softly. Fortissimo plays it very loudly. So just looking at staccato and the pianissimo and the fortissimo, all of a sudden now I have a language. I have a music that says da 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 da. I will not sing any more Mozart for you this evening, okay? But you begin seeing that this has great meaning to it as well. It's not just notes on the page, it's giving me how I should render that. So now when you look at HTML, I hope you're not seeing syntax. I hope you're seeing semantics. I hope you're seeing meaning. Because they say things like, oh look, this is in the English language. When I start talking about internationalization later this week, this lang attribute will become very important because Hindi is very different than Tamil, which is very different than English. And so we need to add meaning to this document so we understand how to render it. We've seen that there's a head and a body to all of our HTML documents. I love this metaphor, right? You can't see what I'm thinking, can you? You can't, can you? All right, good. All right, just wanted to make sure. You don't know if I'm thinking about desserts or not. But on my body, you can tell if I've been thinking about desserts or not, right? Yes. So in our HTML document, our body is what I can see, and our head is what our document is thinking. And when we start saying swapping songs is a header one, that's an important header. Tonight I swapped some songs with some friends who... extraneous space, extraneous space, extraneous space, carriage return, carriage return, carriage return, right? This forms a paragraph, and when we see how it looks rendered, we see that the semantics won. Remember when bread all flowed together and you said that was a bug? That was a feature. You had just not added any meaning to that document. And the meaning of this document now is this is a paragraph, regardless of how it is sent down to me. I want this all to show up as a cohesive paragraph. Semantics, not syntax. So much of what we do with HTML is about how it appears, how it looks on the page. You can't ship it until it looks good. I get that, right? But I'm going to say it again. HTML elements are for defining semantics, not styling. We have something else for styling, don't we? CSS. It's in the name, cascading style sheets, right? And so now we have meaning as well as styling. And so to see this in action, here is our bread HTML once again. And you say, Scott, I just want those first three words, no need bread. I just want them to be in a block all their own, right? I say, all right, here you go. Anything you put in an angle brace is meaning. This is you whispering to your browser. This is saying, I'd like you to make this text a block. Now, block, of course, isn't an existing HTML element. It doesn't standardize across all browsers, but it still works. If you put block around no need bread, and render it, I say, there you go, congratulations, you're now an HTML developer. And you say, wait a second, you played that trick on me before, right? I said, yes. You've done everything you were supposed to do. You added semantics to that document. You've told the browser that this is a block of text. Now, the browser didn't know what to do with that whisper, but it did pay attention. It now knows that that is a block. And the way we can tell is if we use a style block. This again is you whispering to your browser, isn't it? This is you whispering saying, hey, anytime you come across a block element, what I'd like you to do is display it as a block. The default display mode of HTML is inline. So if you don't put any elements in there, the reason you get that flow through there is because everything is inline. So what you're doing now is saying, anytime you come across a block, I'd like you to display that as a block, not display it as inline. And you see that tiny little indentation up there. I say, congratulations, there you go. And he said, well, wait a second. No, I wanted it to be bigger as well and bold and a different color and all that. And I'm like, well, I gave you the raw ingredients. You now have styling and semantics available to you. But you're going to be much happier if you use what's already baked into the browser. And so if you take a little bit of time, I'm sorry, to read the instructions, to know what elements are available to you. These elements have meaning and styling associated with them as well. And so if I go in and I say no need bread as a header 1, what I'm saying is that it's more important than ingredients and instructions. They might visually appear larger than the other one, right? But when I say visually appear, that's styling. The semantics are what are most important. And we've talked about paragraphs, but what about an unordered list? A UL with a bunch of LIs, list items inside of it. We know that if you say this is an unordered list with list items, it will end up being rendered as a bulleted list. Because really, the order of ingredients isn't important, right? We typically try to list the biggest ingredient first, which is flour, and then the next most important ingredient and next, and so on. But really, this is truly unordered. It doesn't matter how you gather these ingredients in your kitchen. Now, the instructions, while that's an H2 as well, that's in an ordered list, an OL, instead of an unordered list, LI. And what's different? Well, of course, that shows up on my screen numbered, but the meaning has been changed as well. What happens if you mix all your ingredients together and then put them in the oven and then turn on the oven? The order is important, isn't it? And so we've identified that by saying this is an ordered list. These list items must be performed in ordered sequence. An unordered list means you can grab the flour first or the yeast first or fill up your water first. We don't care. It's truly unordered. And to really drive this idea home, let's focus in on those header 1s and header 2s. Because if all you look at the appearance, you seem to think that a header 1 is bigger than a header 2, not more important than a header 2. When we go back to our spec and read, we see these elements represent headings for their sections. In fact, what we're doing is every time you use a header, you're creating a new section implicitly. Now, people look at that and they're like, well, that's not how I write my HTML. I say, no, of course not. This top example is how most all of us write our HTML. But what we lose sight of is every time we create a new H2, we're creating a new section, a new node in the DOM. And so these two examples right here with H1, H2, H2, and H1 section H2, these two snippets are semantically equivalent. They mean the same thing. In fact, I end up using that section header sometimes when I really want to make it clear that this is truly a section. Oftentimes I'll just put H2 in and I'll say there's an implied section underneath this. But If I use my style block to make an H1 smaller than an H2, have I in fact changed the semantics at all? No, of course not. So if I went into my style block and I said for every H1, I want you to make that a font size of 1M. M is a typography measurement that goes back to the Gutenberg Bible days. It's literally the width of the letter M in the alphabet. And the M is typically the widest letter in at least the American alphabet. And so they say this is our relative measure. So if something is 1M, it's like your M will be the same size as just the normal body text in your document. 1M means make your text the width of one regular M. If you want it to be 2M, it'll in fact be twice as big. So what have I done here? I've said an H1 will be just the same size as regular text, and H2 will in fact be twice as big. When we render that document, we can see my head 1 is small, my H2s are big. Have I changed the semantics at all? Not in the least. Have I changed the styling? Yeah, absolutely. If you read the spec, they say H1 through H6 elements must not be used to mark subheadings or subtitles or alternate titles or taglines. And that's when I start looking over my shoulder and saying, rats, I've done every single one of those examples before, right? Before I read the instructions. I thought that it was about appearance. In fact, it's about semantics. And what a wonderful way to experience semantics is to take away the visuals altogether. If we take the visuals away, you won't be tempted to conflate semantics with styling because we will take the styling away. The best way to do this is through assistive technology. Now, this is baked into your phones. Now, I have an iPhone here, so I'm going to show you this in iOS. Understand that Android has absolutely the same capabilities. Windows have exactly the same capabilities on desktops, on tablets, on smartphones. What I'm going to show you here is just one example of something that's available on every major platform. Now, I did shoot a video of this just to make sure that the demo gods wouldn't be too unpleased with me. But the demo gods have been pleased with me so far today. So let's see if I can tempt fate and give a live demo of this. And if you enjoy this, my next presentation right after this is going to be an entire presentation on accessibility. So let's see here. All right, that's me. But what I want, oh yes, is my iPhone. Here we go. And I'll see if I can even pump sound through here as well. All right. So I have my iPhone up and running right now. I'm actually driving this right now. This is live. Yeah. If I want to hear the semantics, all I have to do is click 3 times on my button. Now I have to turn on accessibility, right? And we'll talk about that in the next session. But right now, if you've turned on accessibility, a triple click. No sound? Oh, the demo gods are in fact angry with me. All right, which is why I had the video. So let's turn around and use the previously recorded example of this.
Portrait. Headings.
I'll narrate as we go.
Voiceover on. Safari. Address. 192.168.1.108.
I've just triple
Double tap
clicked.
to show controls. Portrait. Headings. 3 links. Form controls. Tables. Form control. Links. Headings.
What I've just done there right now is quite literally turned an invisible knob on my screen. So I am using my two fingers in a twisting motion to twist back and forth. And those various headings you saw, headings, links, table, are the semantics that I can work my way through. And so if we continue watching this now.
Headings. No need bread. Heading level 1. Ingredients. Heading level 2. Instructions. Heading level 2.
Swipe, swipe, swipe to the right. Swipe, swipe, swipe.
Screen curtain on.
Oh, triple
Ingredients.
tap.
Heading level 2. No need bread. Heading level 1. No kneading required. 4 simple ingredients, baked in a Dutch oven. The result is simple perfection, hands down the best bread you'll ever eat.
Triple tap.
Screen curtain off.
If you want to hear the semantics, you have a device in your pocket that will let you hear the semantics. All you have to do is reach into your pocket, triple click on your phone to turn on audio, triple tap on the screen to turn off the screen, and then navigate through your semantics. It's that easy. It's that easy. When people say, I don't know about accessibility and we don't have the right tools or we don't have all those, I say nonsense. It's in your pocket. What's interesting about accessibility is we look at the market share, and that big red bar is Chrome, 63%, almost 2/3 of the browsers. We go on to Safari, which is 13%, Firefox, IE, which is 6%. And when I talk to people, this happened to in a meeting last week. This happened to me in a meeting less than 7 days ago. Someone said, I'm concerned about this because what about IE 11 support? How often have you heard that? I say, IE 11 represents 2% of the market. I am so glad that you want to open the umbrella and make sure that you include all possible browsers, right? Even that 2% of the population who has refused to upgrade their browser for whatever reason, right? But when we're talking about accessibility, that represents 15% of the population. 1 billion people worldwide have some form of disability. Which is more important to you, supporting 2% of the people who don't want to use a modern browser or 15% of your potential user base? By simply pulling the phone out of your pocket, triple clicking, and experiencing semantics without the visuals. And the reason I like coming to India is because this should be deeply important to you. India is home of the world's largest population of blind people. Out of 37 million people worldwide, 15 million, almost half of the world's blind population is right here in India. And that's completely blind, no vision whatsoever. If we expand that to include low vision, it's a spectrum, right? If you include the full spectrum of sight loss, that's tenfold. That's 150 million people that you could be supporting through accessibility, or 2% of the world that is still using an antiquated browser. The choice is up to you. The choice is up to you. And unfortunately, we've made that choice as an industry. When we go out and look at the top 1 million websites, the top 1 million websites in the planet right now, there are 60 million unique accessibility errors. And you say, wait a second, I thought we were talking about 1 million websites. Yes, there are 60 million accessibility errors on 1 million websites. That is 60 errors per page. That is 1 error every 13 HTML elements. These are real numbers. These are real numbers. And we look at what the faults are. 85% of all web pages have low contrast text. Is that solvable? Easily. 68% of all images are missing alt text. 68% of all images are missing alt text. Is this solvable? Easily. We have empty links. We have inputs that don't have associated labels. All of these are semantics errors. Would you go to market if you had a bug in your software that affected 150 million people? Would you go to market if you had a bug, a showstopper bug that prevented 15% of the planet from using your website? And the answer is yes. We all are. We have work to do. We have work to do as an industry. And you might think that frameworks will help us out. Oh, goodness. Here we go. So, React had an average of 65 errors per page. That is 10% more than the average. If you use Angular, you have on average 20% more accessibility errors on your page. If you use Vue.js, you have 25% more accessibility errors on your page. Now, the study goes on to say we're not saying the framework forces these errors. It's not the cause of these errors, but there's a correlation, right? That on web pages that use React, there are 10% more errors on the page. The cause is up to us to determine. Tim Berners-Lee says the power of the web is in its universality. Access by everyone is an essential aspect. And so people are concerned about IE 11. I appreciate that. They are expressing this, right? That they want to make sure that this website renders well on IE 11. And I applaud that, and I want people to continue to focus on that. But I also want you to prioritize your efforts and make sure that your hard efforts are getting the right level of payoff. So, goodness, that's just HTML, right? What time does the session end here? 5:20. All right, we've got plenty of time. I'll just talk faster. How many of you in here are JavaScript developers? You know what I'm going to ask you next, right? How many of you read the ECMAScript spec? I see a pattern forming. Do you? So, there is a history of JavaScript we should be aware of. The first 4 versions of JavaScript ended about December 1999. That is IE6 era. That is when most people stopped learning JavaScript 20 years ago, yeah? That we in fact have had significant improvements to the language since 2009, and in the last 4 years we've had new releases of JavaScript every year. Now this is news to many JavaScript developers. Why? Because you don't npm install JavaScript. It's just available to you in your browser. So people are blissfully unaware of the changes and the new capabilities in the language that you are already running on. So I don't have time to read you the whole spec, but I will start by saying, hey, ECMAScript provides a host environment for client-side computing, including windows and menus and pop-ups and dialogues and all that. Further, the host environment provides a mean to attach scripting code to events. JavaScript is event-driven, and so when we click on a button, we're going to have a click listener. When we swipe on the screen, we're going to have a swipe listener. Mouse down, mouse move, mouse up. Everything about JavaScript is event-driven. Now, these are the keywords. There are only 34 keywords to the language. It should be easy for us to read the spec and understand what these 34 words mean. But there's one word that I find especially interesting when it comes to the scripting element, where, of course, you put your scripts. So now we understand that HTML is semantics. We put our styling in a style tag. We put our scripting in a script tag. But perhaps the most important attribute of that scripting tag is the defer attribute, which tells the browser you can download this JavaScript, but don't execute it until the DOM is fully loaded. You need to wait for the HTML to load before you start running JavaScript against it. Now, most of us solve that by moving all your JavaScript to the bottom of the page, right? That's the caveman banging rocks and counting the pebbles method of doing this. It will almost always work, but not always. And when it doesn't work, you say, stupid JavaScript. When instead you could add one attribute defer and that would do exactly what your intentions are, because what are we doing? We're adding meaning to our HTML once again. Scripts at the bottom of the page don't mean anything, but scripts with a defer attribute mean wait for the DOM to be loaded before you begin running. Now, this only works if you do a script source, if you import external scripts. If you want to do this by hand, you can do that as well. What we do is we add an event listener. We want to wait for the window to start loading, defer equals true, right? And once that window is loaded, we can call a init. We will select button. And by the way, that query selector we're using is exactly the same language we used for CSS. When we said block, display block, we're using the same syntax that we use in query selector. This will return the first button it finds and attach an event listener to it. This grabs all of the paragraphs, but this is using the same CSS selector syntax that we used before. And now all of a sudden, we have a new speech synthesis, which in fact makes it read. The demo gods can't be that angry with me, right? So if we come in here right now and run this, here's my read button.
4 simple ingredients, baked in a Dutch oven. The result is simple perfection, hands down the best bread you'll ever eat. The simplicity of this no-knead bread is what I love the most, and the fact that your entire house will smell of fresh bread as you bake this. This bread could not get any easier. It's even easier than the artisan bread.
So now all of a sudden, we don't even have to play around with accessibility, right? That we were able to go in right there and just use this as expected. So in this amount of code right here, now we've added event-driven behavior to our element. And in this amount of time, you know everything there is to know about HTML. The rest are just details. But you now know that HTML elements are all about semantics. We know that CSS is for styling. We know that JavaScript is for event-driven behavior. So, here's our good friend Alan once again. Fools ignore complexity. Pragmatists suffer it. Some avoid it. Geniuses remove it. Oh boy, he's going to talk about frameworks again, isn't he? Right? Yes. Yes, I am. Because all of these same frameworks, I've worked in all of them. I haven't worked in Vue, but I've got a lot of respect for it, right? But I have some concerns. And these concerns come from my 30 years of experience in the industry, because we're experiencing something now that we haven't ever experienced before. These frameworks are maybe not the net positive they have been up to this point. Now, I loved this tweet. The legendary Apollo programmer Margaret Hamilton next to a printout of the node modules directory listing for her Hello World React app. There's only one lie in that slide, and that, of course, that it's not a Hello World React app, right? That is Margaret Hamilton. She is the software developer that put astronauts on the moon. That is truly her standing next to the source code. She's 5 feet tall, so that's an interesting way of measuring this, right? As a matter of fact, when we use the phrase computer engineering, that's because of Margaret. She coined that phrase. She popularized that phrase. All of you on your business cards have Margaret Hamilton to thank. But this is what I love about the internet. Well, what if that was a Hello World app? What would this actually look like? Well, let's see. I feel like I could get about 49 lines of code per page. And that means that, well, wow, a Hello World app has 2.6 million lines of JavaScript. I'm going to say that again. React Hello World has 2.6 million lines of JavaScript. So what that means, if we multiply this out, it'll only take us about 18 feet of paper in order to print out the node modules directory of a React Hello World, right? This photo is clearly not to scale, right? Now, someone helpfully pointed out that, hey, that's single-sided. If you printed out double-sided, it would only be 9 feet tall, right? I said, yeah, that's the kind of thinking we need, right? Margaret Hamilton would no longer be 5 feet tall. She would be twice as tall as she was. This is the code that put a man on the moon versus the code we carry around with us to write a hello world in React. This comes with real problems. I did this NPX Create React app. I did this just last week. And what I ended up with is close to 2,000 packages from 735 contributors that gave me 68 security vulnerabilities out of the box. Happy hacking. This is a problem. This is a very serious problem. When we have done studies of websites out in the wild, the top 133,000 websites, they found that 36% of all jQuery includes had security violations in it. We found that 40% of Angular includes had significant security flaws in it, and that 86.6% of all Handlebar includes had significant security flaws. We also found that the average website, the median website, has libraries that are over 3 years old. When we use frameworks, we are absolutely committed to keeping up to date with these frameworks. When you are deferring your application to someone else, at the very least, you're committing to keep up. Or not. They said that only 1.6 of the .coms they surveyed, only 1.5% of the websites could be fixed by a single patch upgrade. What that means is because your libraries are 3 years old, you're not a simple patch upgrade away. You are several major versions behind, which means this is a non-trivial way to solve security problems. This was true in Angular as well. There was only one high severity vulnerability in Angular. But when I did Vue, I thought this was interesting. There were no security violations, but there were warnings. If you read this warning that the deprecated cross-spawn async 2.2.5 cross-spawn no longer requires a build tool chain, how would you fix that? I don't know. I don't even know what an async cross-spawn toolchain is, right? Hey, node pre-jip warning. Use request for node pre-jip HTTPS download. What does that mean? TS node requires a peer of TypeScript, but none is installed. You must install it yourself. Do you read these warnings when they come by on your screen? Absolutely not. So you would npm install this and go about your happy business. And in the React world, you would be shipping 68 known vulnerabilities to your website. Is that production quality code? Not in the least. The median web page has 350 kilobytes of JavaScript downloaded. A 15-second time to interactive. 15 seconds. You know that if your website takes over 3 seconds to load, you will lose over half of your users. In 3 seconds, you will lose 52% of your users. How many users do you think you have left after waiting for 15 seconds? When we look at this page weight size and say 350 kilobytes, what we're looking at right here, a 50% median, that means that half of the web is shipping less JavaScript and half of the web is shipping more, right? That's what median means. So half of the web is shipping 420 kilobytes. This, by the way, comes from the HTTP archive, as does this. from the HTTP archive. The only difference was these stats were pulled in July of 2018. These stats were pulled in October of 18. That's why the numbers are off just a little bit. But half of the websites were shipping 420 kilobytes of JavaScript or less. 75% of the websites were shipping 780 kilobytes or less. The top 10%, and the wrong kind of top, right? Top 10% of the websites are shipping 1.2 megabytes of JavaScript. And you're like, well, okay, 1.2 megabytes, that's not bad, right? Facebook ships 7.1 megabytes of JavaScript. That's React. One megabyte of JavaScript takes 5 seconds to download on a 3G network. We're in a mobile majority world right now. Over 75% of the world uses a 3G or slower network. This is simple arithmetic. If you download less than a megabyte of JavaScript, you will have reasonable performance times. If you download 7.1 megabytes of JavaScript, there's no hope of you ever hitting that mark, no matter what. This is one of my favorites. When people talk about React, they're like, oh, we use React because it's so fast. It's faster than the DOM, right? Dan Abramov, who is the lead contributor to React, and he wrote the Redux framework, a very well-spoken fellow. I got a lot of respect for him. He says, no, we don't claim that in the React documentation. React can't be faster than the same DOM mutations written by hand because by definition, it has to do more work. There's no possible way that React is faster than DOM. But you know what's nice about this? We can measure it. This is empirically provable. And someone did all the hard work, which is even better. I love the internet, right? Someone went on and said, what I like it does is he starts by saying, I like React. This is not a hit job. I am a fan of React. When I wrote a sample app, which is a simple HTML table of 100 employees being downloaded by JSON, I used ECMAScript 6 templates, so raw JavaScript. I used Nunjucks and Pugs, two very popular templating libraries. Of course, I used React. And then he said, oh, and I used static HTML as well. And I measured the output. You can't see the numbers, and that's okay. Do you know what the tallest bar on this chart is? Static HTML. Do you know what the shortest bar on this chart is? React. This is dramatic. This is dramatic. And he went on to say, oh, you know what, this green bar down here, silly me, this is React in dev mode. When I put it into prod mode, that'll fix it. Do you know what the second shortest bar on this chart is? React in prod mode. So React in prod mode gives you 1,600 requests per second. Vanilla JavaScript gives you 2,700 requests per second. Static HTML gives you 3,900 requests per second. If you look at it the other way, what your response time is, the largest bar on this chart is React. The shortest bar on this chart is static HTML. Even in prod mode, we go from 150 milliseconds per request to 70 milliseconds per request in JavaScript, up here 50% reduction, to 30 milliseconds per request, a full 5 times faster than React. We're beginning to see a wave. This is a lovely video, a framework author's case against frameworks. This is by the author of Django. He says, Django solved a very specific problem for me. I don't use frameworks anymore. Netflix removed React from their splash screen. Now, very importantly, they didn't remove React through all of their app. This is just their initial splash screen. By removing React from Netflix.com, that homepage, they saw a 50% in performance improvement out of the box, doing nothing but removing this framework. We see story after story after story telling us the same fact. This shouldn't be a surprise. You download HTML, you download CSS. We saw it on the chart right there incredibly fast. The minute you start adding 7 megabytes of JavaScript, you are absolutely going to slow down. This shouldn't be the least bit controversial. It's simple arithmetic. So where does this leave us? With 1 minute left in my talk. We're going to go longer than 1 minute, but not much longer, I promise you that. Simplicity does not precede complexity, it follows us. This brings us back to this idea of framework-free development. Because simple is harder than complex. You have to think about what you're doing, not just copy and paste code from Stack Overflow. This is an even better quote. This is from Rich Hickey. The text is small. I'll read it to you. Rich Hickey, the creator of Clojure, says, simplicity is hard work, but there's a huge payoff. The person who has a genuinely simpler system, a system made out of genuinely simple parts, is going to be able to affect the greatest change with the least amount of work. She's going to kick your butt, shall we say. She's going to spend more time simplifying things up front, and in the long haul, she's going to wipe the plate with you because you'll have the ability to change things while someone else is struggling pushing elephants around. Simplicity is something we should focus on. So I've got many examples out on the web. I have a roll you're on Google Maps. I got my start working on pre-release Google Maps. I wrote several books about Google Maps and open source. This is 10 steps to take you to a Google Maps clone with 150 lines of JavaScript. You can see the code up at Thirstyhead. That's my GitHub repo. Thirstyhead. Roll your own Google Maps, RYOGM, and you can run this code and see it yourself. 150 lines of JavaScript. This framework that I'm using right now is one of my own writing. I call it Taco Vision. Talk, not T-A-C-O, like the food, but talk, T-A-L-K-O Vision. It's because if we go out and see this on the web, I don't have time. I'm sorry, I shouldn't do that. What I've done with this is not only provided the slides you're seeing, I've provided a written transcript, I've provided audio, and I have translations in English, Chinese, Italian, and I am one pull request away from having a Hindi version of this as well. This is browser native technology, nothing but HTML, CSS, and JavaScript. I can do all that in 350 lines of JavaScript. You can see it up on my GitHub repo, Thirstyhead Taco Vision. And finally, I have an example that you'll see throughout my presentations called Grocery Works. It's a fictional website, but it's a way of getting you into graphics and moving around and single-page apps and things like that. If you go to /demo, you'll begin seeing web components implementations of Grocery Works and PWA implementations and Alley versions and all that. 250 lines of JavaScript. These should be your expectations. We don't need 2.6 million lines of JavaScript when we can accomplish the same thing in hundreds of lines of JavaScript. So where does this leave us? Anxious to leave, right? Congratulations, you've now read a tiny portion of the HTML spec. I encourage you to go out and look at it. It's not a bad read, but it is professionally responsible for you as web developers to be familiar with this. If you are a JavaScript developer, it's professionally responsible for you to have at least skimmed the specs so you know what's going on. If you're a web developer, it's professionally responsible for you to go into your phone and turn on accessibility so you can triple click and you can hear the importance of your semantics, not just see the importance of your semantics. Because 98% of the web pages have accessibility errors in them, easily avoidable. And this is not how we build the web, or shouldn't be how we build the web. If you start looking at getting rid of frameworks, there are very real reasons why we can turn around and improve performance, not a little bit, dramatically improve performance by avoiding frameworks. We can dramatically improve security by avoiding frameworks. Remember, 68 security flaws from your generator. We can dramatically improve accessibility all by simply focusing on the core ingredients, but never losing sight that our goal is not to produce flour or water or yeast, but in fact, it's to produce naan. Did you enjoy yourself? I did as well. Namaste. Thank you so much. Dhanyavad. Thank you.